Okay, class, so this is a continuation of section 1.6. Now we're going to talk about solving a radical equation. In the last video, we talked about solve by factoring. Now, solving radical equations, if you recall, a radical would be when we're using the square root sign. So an example problem to start with would be the square root of 6 minus 2, 6x minus 2 is equal to x plus 1. If necessary, what the first thing we want to do when we are faced with these problems is isolate the radical on one side, but there's no need to do that here because it's already there. So the radical is already here on one side. So all we have to do now is to square both sides in order to get rid of that square root sign. So I'm going to come here, I'm going to say square, I'm going to come here, and I'm going to say square. Now, once I do that, then I just have 6x minus 2 is equal to x plus 1 multiplied by x plus 1. Then 6x minus 2, x and x, that's x squared. Then 1x and 1x, that's 2x plus 2x. Then 1 times 1 plus 1. So now that I have that, I want to have a 0 on this side, so I'm going to take this here and move to this side. The only way I can do that is subtracting 6x on this side and adding a 2 on this side. Once I do that, I'm moving everything over here. So if I subtract 6x here, I'll add it over here. So this will end up being x squared plus 2x plus 1 plus 6x. And if I add 2 here, I'm sorry, this will be a minus 6x. So this is minus 6x. If I do that there, then I have minus 2 is equal to x squared plus 2x plus 1 minus 6x. Then I add 2 here. I'm going to add 2 over here somewhere. So then I have 0 is equal to x squared plus 2x plus 1 minus 6x plus 2. I can combine my like terms. Then if I do that, I will have 0 is equal to x squared minus 4x plus 3. X squared minus 4x plus 3. Once again, I can put it into the quadratic equation, or I can see if I can factor this. I'm not going to do the quadratic equation like I did last time in the last video. I'm just going to go ahead and factor this because for me, factoring is just a lot simpler and quicker to do. So this will be x minus 3, x minus 1. X minus 3, minus 3, x minus 1 equal to 0. Then I set each of these equals to 0. So x minus 3 equals 0, x is equal to 3. X minus 1 equals 0, x is equal to 1. And those are the final answers for this problem here. 3 and 1. All right? Okay. Now, erase this. And we're going to do solving an equation with 2 radicals. Solving an equation with 2 radicals. Solving an equation with 2 radicals. All right, so if we're solving an equation with 2 radicals, first, let me just write the equation out so we can have something to reference and go to. So, square root, we'll come over here. So when I start over here, you know that it must be a lot of steps to this problem, right? So square root of x plus 5 minus square root of x minus 3 is equal to 2. Is equal to. So first thing we want to do, as I said in the last problem, isolate the radical on one side. So we have 2 over here, but we're going to just move 1 to the other side so we can have 1 over here. And then we're just going to do a square root of both sides. But this one, it can be tricky. So we're going to use a formula when we get round to it. A formula that's going to say a squared, well, a plus b squared is equal to a squared plus 2ab plus b squared. But we're going to hold off and wait till we get there. So, but I want to just write it just for reference. So when we get there, I want to write it over again and erase it and write it over and erase it. So now we have x plus 5, square root of x plus 5 is minus square root of x minus 3 equals 2. If I add square root of x minus 3 to both sides, equals square root of x minus 3 to both sides, well, then this is going to cancel out. Have square root of x plus 5 is equal to 2 plus the square root of x minus 3. Or, the other way around, x minus 3 plus square root of 2. Now, I want to square both sides so I can get rid of these square root sign. Well, at least I know I'll be able to get rid of one of them anyway. This one right here. So this will just be x plus 5. Now I have 2 plus square root of x minus 3 squared. So in this problem like this, it's similar to this. We can apply this a plus b squared is equal to this right here. But first we have to pull out our a and our b. Here, our a is 2, and our b is square root of x minus 3. So knowing that, let's go ahead and apply that. So a squared, 2 squared is 4, plus 2 times a, 2 times 2, times our b, square root of x minus 3, plus b squared. If x minus 3 is that squared, it's just x minus 3. So now that we have that, let's see what we can do here. Continue to bring our x plus 5 down. This is 4 plus 2 times 2 is 4, x minus 3 plus x minus 3, square root of x minus 3 plus x minus 3. Now, let's see the other things we can do. We know we have some like terms here, some things that we can get rid of or just bring together. Let's go ahead and bring our x over here. If I subtract x here, subtract x there, it's going to get rid of this x. So now I have 5 is equal to 4 plus 4 on the square root of x minus 3. This cancel out, minus 3. So next thing I could do is I could just subtract that 4 from both sides, or I know that this 4 and 3, that's 1. So really I could have did that step up here if I wanted to, but I'm going to do it right here. 4 minus 3 is 1, plus 4 square root of x minus 3. So now that I have that, what I can do here is I can subtract 1 from both sides, because I'm trying to get my square root on one side. So now if I subtract 1 from both sides, this is 4 is equal to 4 square root of x minus 3. Okay, I'm almost there as far as getting my square root sign on one side. So now that I have that, I can square both sides here. So if I square this, then I'll come over here and square this. This will be 16 is equal to 16 x minus 3. So 16 is equal to 16x minus 3. Now, that 16 I can distribute through that parentheses sign. So this would be 16 is equal to 16x minus 48. 16 equals 16x minus 16 and 3, that's 48. Okay, I'm going to bring this right up here because I'm running out of real estate down there. So that right there is saying, well, I'm going to erase this as well, so I can bring it up a little bit higher, just in case I need more room to write. Okay, so now what's down there is 16 is equal to 16x minus 48. So then I can add my 48 to both sides. If I add my 48 to both sides, so this is plus 48 here, plus 48 there. It's going to cancel out. This right here, 16 plus 48, that's 64. 64 is equal to 16x. Then I hope you're familiar with this step here. These 16s cancel each other out. And what if our x? Our x is 4, exactly. So our x is 4. Now, if you come back up here and look at this, we just could not square this one and square this one over here because it would not have gotten rid of this square root sign, because we have this minus sign here. But if you notice, once we came down to this step right here, where we did not have that minus sign in between, then we could square both sides and we were able to get rid of this square root sign as well as square this 14. So, I'm not square to 14, square to 4. So that gave us that 16 and just remove that square root in x minus 3. Then from there, it was all downhill. But the key here that was very different, like I said, this can really be tricky, is when we got to this part right here. We got to this part right here, and I had the formula up there, a plus b squared is equal to a squared plus 2ab plus b squared. Once I did that and plugged this in, then some things canceled out, and I was still trying to get my square root sign on one side and my other stuff on the other side. Once I was able to do that, that's when everything came a lot more clear. So problems like this, it's going to take a little bit more time, a little bit more practice, but as of anything, you can do it the more and more that you practice it. So the last one I'm going to do for this section is, let's see, we did solve by factoring, we did solving a radical equation with two radicals. Now let's do solving an inequality, solving an equation involving absolute values. So solving an equation, I'm just going to say with absolute values, So if we do that, the equation would be something like 2x minus 1 is equal to 5 as our absolute value sums. Now, there's a rule here in the book. It says if, I'm reading this off a piece of paper, if C is a number, a positive real number, a positive real number, and it represents any algebraic expression, then absolute value of u equals c is equivalent to u is equal to c or u is equal to negative c. So we have this here, u equal to c, and it said it's equivalent to 2x minus 1 is equal to 5, and 2x minus 1 is equal to negative 5. U is equal to c or u is equal to negative c. Then once we have that, we just solve for it. So putting this 1 on this side here, that will give us, we got to add a plus 1 here, plus 1 there. 2x is equal to 6. Divide both sides by 2. X is equal to 3. Then we add a 5 here, add a 5 there. 2x is equal to negative 4. Divide by 2 here and a 2 there. X is equal to negative 2. So we just applied that to this problem here. X is equal to 3, x is equal to negative 2. Only thing that we did was say 2x minus 1 is equal to 5, 2x minus 1 is equal to negative 5, and then solve for x. So we're going to do another one. I'm going to keep this here just so you can reference it. So the next problem is 4, absolute value 1 minus 2x minus 20 is equal to 0. So let's go ahead and move the 20 over here because we're trying to solve for x. So it's 4, absolute value 1 minus 2x is equal to 20. We can do that because we're adding 20 to both sides here. So that's how we got the positive 20 here. Now, we still need to get the absolute value sign all by itself, but right now, the 4 is attached to that. The only way we can get it by itself is by dividing by 4 on both sides. So if divide by 4 here and divide by 4 here, this is going to cancel that out. Then we have 1 minus 2x is equal to 5 there. So 1 minus 2x equal to 5. Now, we're right back in the same setup as we had for the previous problem. And it says that the absolute value of u is equal to c. We can say u is equal to c or u is equal to negative c. So we can say 1 minus 2x is equal to 5. 1 minus 2x is equal to negative 5. And now if we subtract one here and subtract one there, it's minus 2x is equal to 4. Divide both sides by a negative 2. Remember, that is negative. If we do that, then our answer would be x is equal to a negative 2. Now we come over here and we do the same exact thing. Subtract one here, subtract one there. Minus 2x is equal to a minus 6. Minus 2 and a minus 2, this cancel out. X is equal to a positive 3. Why a positive 3? Because a negative divided by a negative is a positive. So, right now, this concludes this video here, but we'll have one more video, which is equations with rational exponents. So stay tuned.